Hey everyone, Mr. Smith here, and in this lesson, we're going to solve linear quadratic systems, which is a fancy way of saying we're going to find the intersection points or points if they exist between a line and a parabola or a linear function and quadratic function. So what we're doing here is what is needed is actually just grade 10 stuff. So it's a nice lesson for a bit more review of working with quadratics from grade 10. But it's also something you might not have done before, so it's a little bit of extending into grade 11 stuff. So it should be fun. Now, what I've done for you guys already is I've graphed a quadratic function. You can see the parabola on the image there, negative x squared plus 6x minus 5. And I've given you a line, and I want you guys to graph the line and then see if there are any points of intersection. So I've given you 3 different lines for the same parabola. So if you want to pause the video and give those a try, then you can pop back in when you're done. I'm going to do them right now. Yeah, hopefully you pause and try it yourself. That's always best. Okay, so 1/2 x plus 5, y just to 5, and the slope is 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, back. Okay, so when you sketch that line, it looks like this line and parabola never meet. None. Which kind of makes sense, right? Like if you have a parabola, in this case it opens down, it's fully possible to have a line like completely above it. So hopefully this is common sense and you can kind of see this proved here is that, it's totally within reason for a parabola and line like never to meet at all. And that's what we've seen in this case. So it's possible that they don't have to meet. Let's do this one. So 2x minus 1. So minus 1. And the slope of 2. So up 2 over 1. Up to, there we go. Up 2 over 1, up 2 over 1. Visually, I was like, this isn't going to work. But then I realized I was going up too far. So you can see just by the dots, and if you just do your best to connect that with a straight line, you can see that in this case, that there's only one point of intersection. That line just meets the parabola at the point 2, 3, and then keeps going off. So it's possible for a line and parabola to only meet one time. Let's look at the last case, negative x plus 5. So a y-intercept of plus 5, and down 1 over 1, down 1 over 1. There's one point of intersection. But if we keep going, we can see a second one as well before the line kind of pops back out. I'll stop there. But what we can see is that in this case, there's 2. This line meets that parabola at the points 2, 3, and the points 5 and the point 5, 0. So we've actually just solved 3 linear quadratic systems. We found the intersection point between a line and a parabola, and we did it by graphing, right? And as hopefully you're convinced, there's 3 different scenarios that can happen. So the first scenario, I'm not sure if I have this typed out or not. I do I? Save myself some writing? I do. The line and parabola don't meet at all. So that's like our first case, right? So our first scenario looked like this, parabola and line, and they never met. But there's lots of ways that can happen, right? I'm going to draw here's a parabola like that. A line like this would never cross it. So lots of ways to illustrate that happening. Our second outcome was that the line and parabola intersect twice. Or that's a second possible outcome. That happened to us in the very last one. So let me just, here's a parabola that opens down. Here's a line that meets it twice. Or you can have one that opens up. Lots of ways this could happen to line that meets it twice. The third case, kind of the interesting one, is the line and parabola can intersect once. That is possible. And in situations like that, we give the line a special name. We say the line is tangent to the parabola, meaning it only touches once. You may have talked about tangents in your grade 10 course if you got to the analytic geometry unit and did some work with circles. When you get to calculus, if you choose to take calculus, you will work a lot with tangents. They're very important. They kind of tell you, like, lines have slope. Bit of a side thing here. We've all talked about the slope and steepness of a line. For a curve, it's worth asking, well, what is like the instantaneous rate of change, or what is kind of like the instantaneous slope at a point? And you're going to develop some other mathematical tools for finding that, because normally you need 2 points to find a slope. Anyway, yeah, it's a tangent line. Maybe I'll just get another example of a tangent line. Maybe I'll draw this one like horizontal. But yeah, those are situations where there's would just be one point of intersection. So those are the three possibilities. It can't be anything else. And what we want to do is, because it's not always practical to graph, we want to learn an algebraic way to do this. So let's get started. Now, first of all, regarding the math, if you recall, the discriminant of in the quadratic formula had three cases, giving you 0, 1, or 2 solutions depending on the sign. That's going to be helpful for us because as you can see, we can either have 0, 1, or 2 points of intersection. So add a little note here: the discriminant is going to come into play mathematically when we're seeing which case it is. Let's just do an example. So we already know the result of this, right? This is the last case. We drew this case already in our little investigation, because I drew the function for you, the quadratic function, and you drew the line. So we know our 2 points of intersection. Let's see how we can find these algebraically, because sketching isn't always practical. So we actually use a strategy from your grade 10 math course when you did linear systems. When you have two equations that are both y equals and y equals, since y is equal to both of those things, you can set those things equal to each other. And you can create an equation with no y by setting those equations equal. And we're going to solve the resulting quadratic equation. So we like to use any of our strategies. We have to have everything grouped together on one side. So I think it makes sense to do the left side. So bring over negative x squared, you get positive x squared. I'll just show this work actually. Negative x, if we bring over the 6x, we get negative 6x. Plus 5, bring over this negative 5, we get another plus 5 equals 0. Collecting like terms, we get x squared minus 7x plus 10 is equal to 0. All right, so maybe you could have gone right to that step like in one step, so that's fine. If you needed to show some extra work, just show it however you're used to showing it. So now we have a quadratic equation. It's in our form ax squared plus bx plus c equals 0, and we had lots of strategies for solving these. Typically, many students will just like the quadratic formula. Some students who are comfortable factoring might recognize that you can factor this one. So I'm going to factor it because factoring is the most efficient way to do this one. Because I can see that the two numbers that multiply to 10 and add to negative 7 are negative 2 and negative 5. Which gives me two possible answers. What makes x minus 2 0? Well, 2. And what makes x minus 5 0? X equals 5 does that. The quadratic formula would have given you these exact same values, but in this case, we could factor, and factoring is pretty efficient. So just double checking, guys, we can see that, yeah, when we did it graphically, we got x equals 2 and x equals 5. That's good. So the last thing to do in a question like this, because when you're solving a system, you're finding the points of intersection, is we still need to find the y values. And You can use, just like in grade 10, you can use either equation, but I think it makes probably most sense to use the line because it's pretty easy to plug in. So we're plugging in, so it's negative, we plug in 2, add 5, we get y equals 3. This corresponds to a point of intersection of 2, 3. I'll just write it like that. And when x equals 5, we get negative, and then plug in 5 plus 5, and we get y equals 0. So this gives a second POI of 5, 0. And if you go back and check, those were precisely our two points of intersection. And this is how you guys will solve linear quadratic systems. It's really the same step every time. Set the line and quadratic function equal to each other. Solve that quadratic equation using any strategy that you prefer. And, in this case, the math came out where it was we had 2 x-intercepts. If we're using the quadratic formula, then you would have got under the root, the b squared minus 4ac. You would have saw that b squared minus 4ac have been positive, which means there's 2 x-intercepts. So yeah, the math played out, 2 x-intercepts. Let's try another one. So let's investigate the intersection. So I'm just basically saying there, like, if there's an intersection, find it. If there's no intersection, like, kind of prove it. So our way to do that, set the equations equal. That results in a equation with no y's, which is great. And we need to group everything on one side. Now I'm grouping everything on the left, and you may think that's more work because I have to move 3 things over, but it does make the x squared term positive, which for me is nice. I like that. So 2x squared, and I'm just gonna like show my work here. So minus x, that's negative x, and we had a minus 2, we're bringing over the minus 3. So that's not necessary, but like you could go right to here. 2x squared minus 2x plus 1 equals 0. Now, I'm looking at this equation, and I can see that this one cannot be factored. So I don't like any of the other methods except the quadratic formula. So I'm going to use the quadratic formula. So if you have, so negative b, so it would be, so remember this is a, b, and c, right? So the opposite of b, or negative b, is 2 plus or minus the root of b squared minus 4ac. That's negative 2 squared minus 4 times 2 times 1, all divided by 2a. So at this point, we saw the quadratic formula in grade 10. We've reviewed how to use it. So at this point, when we need to use it, we don't need to spend 5 minutes going through every step. It's kind of assumed you've practiced it a bit and you have some kind of comfort level. Let's continue. So we got 2 plus or minus. What is the discriminant? What's under the root? So it's 4 minus 8. 4 minus 8, we get negative 8 all over 8. So which case is it here, guys? Is it going to be 2 like the last one? Will it be 1 x-intercept or no x-intercept? Think about what the discriminant's telling you here. And if you said there's no solutions, you'd be correct because you cannot root a negative number. There's no points of intersection, no POIs. You can't go any further. You can't root a negative number. And every time I teach this course, there's still a few people that say want to root negative 8, and they just pretend that the negative is not there and just square root it and get an answer anyway, or take the root and make it negative. No, it's not that. This isn't a bad thing. It just means that there's no points of intersection. And to emphasize to you guys the importance of having a graphing program readily available, we can now verify our answer. Let's just graph these two things. So I think I have Desmos open here. Yes, I do. So our line was negative x minus 2. So it looks something like that. And our parabola was negative 2x squared plus x minus 3. y equals negative 2x squared, x squared plus x minus 3. Okay, so we can see that they come close, but no, these guys actually don't touch. So this is something you could have done before the problem, right? You're given the linear quadratic system, and you're thinking, okay, before I solve this algebraically, let's just get a visual. Go on Desmos and graph it. It's not cheating. So now you know as you solve the problem, you're like, oh, this line and parabola doesn't meet. When I'm doing the math, I expect to get a situation in the quadratic formula where it gives me a negative underneath the square root. Because guys, if there's no points of intersection, we expect the formula to break down. Because it'd be weird if the graph said there's no intersection points, but the quadratic formula spit out some meaningful values, that would be bad. This is good though. There weren't any points of intersection and the quadratic formula broke down. So we're actually happy about that. Everything is consistent. All right. One last example to do. So one last example. So this is another, I mentioned our last lesson. Is this a kind of question that's going to be useful in real life? That's going to come up a lot? Nope. Is it a useful problem as an exercise to develop our skills and just get stronger? Yes, it is. So that's where we're going to do it, okay? So we have a line with a slope of 4, and it has 1 point of intersection with the quadratic function 1/2 x squared plus 2x minus 8. And we know the slope. I'm asking you guys to find the y-intercept. So what we have here is we have our, equation 1. It's a line with a slope of 4. We don't know the y-intercept. I'm going to use k just because. The reason I'm using k, normally we use y equals mx plus b, is because these problems involved using the quadratic formula, b squared minus 4ac, et cetera, et cetera. So I don't want to have things mixed up. I'm just going to use k for the y-intercept. That's equation 1. And our parabola, 1/2 x squared plus 2x minus 8. And just to show you guys how you can check answers beforehand and it's not cheating, it's okay. Let's go to Desmos and check this out. I don't often make use of the slider tool, but I think this is pretty cool. So I'm going to just do 4x plus k and add a slider for k. So now I can change the y-intercept of my line. I can make a bigger y-intercept or smaller one. So it kind of shifts the line up or down or left to right, depending on your perspective. But yeah, it changes the y-intercept. So let me graph the parabola too. So we're working with 1/2 x, so 0.5 will be fine, x squared. And then it is plus 2x minus 8, plus 2x minus 8. Zoom out a little bit. So I can see right now they're going to meet twice. They meet down here, and they're going to meet somewhere way up here. But we want them to meet once. So if I do the slider down and down and down, okay, it looks like actually, is that maybe the solution? It looks like if k is -10, if the y-intercept of the line is -10, it looks like that could be the tangent line. So as we do our problem, I'm kind of expecting something around -10 to pop out. So I'm hiding from the light, so I'm really crouched close to my computer. But I think the sun is, can I take the pillow out of the window? Yeah. All right, we can just proceed as normal. So yeah, we know what kind of answer to expect. Let's proceed. So we're going to go like we normally do. So set 1 equal to 2. So 4x plus k equals, I think many of you guys, let's just change that to 0.5. No big deal. 2x minus 8. Yeah, that's okay. I was thinking, should we just multiply the whole equation by 2 to clear the fractions and decimals? And I don't think it'd be any easier. So we can just move forward. I'm going to keep going like we normally do. So normally we put everything on one side. So I'm going to put everything on the right this time because I like the 0.5 being positive there. So what do I get? I got 0.5x squared, and maybe we can do this a bit quicker. 2x subtract 4x, and I should have my 0 equals here. I'm just going to start that line over again. I want everything to be nice and lined up. So we have nothing left on the left. Positive 0.5x squared. 2x minus 4x, that's negative 2x. And then I have minus 8, and I have minus k. So you might be wondering, so how are we going to finish this off? Because we have a quadratic equation here, but we have two things we don't know, right? We have x and k. Well, remember, we are told one extra piece of info, that this has one point of intersection. So here's the key to this problem. When you have a quadratic equation, maybe you're using the quadratic formula, what happens to the discriminant when there's one solution? So this is the key to the whole question. So because there's one point of intersection, the discriminant, which is b squared minus 4ac, is going to equal to 0. So check this out, guys. B is negative 2, so negative 2 squared, minus 4, a is 0.5, and our value for c is minus 8 minus k. We don't know what k is. But because we knew there was one one point of intersection, we knew the discriminant is going to be 0, and that allowed us to set up an equation to ask what value of k makes the discriminant 0 so that this line and parabola meet exactly once. And we can solve this for k. We'll do it in a few steps. So 4 times 0.5, that's minus 2. Didn't mean to put an equal sign there. And then we have minus 8 minus k. I mean, there's so many ways to solve this one. I'm just going to distribute the minus 2. So minus 2 times 8, minus 2 times negative k. So that's plus 16, plus 2k. We get 20 plus 2k equals 0. This is good, guys. 2k equals negative 20. And what did our graph, what did Desmos say the y-intercept should be? It said that it should be negative 10. Negative 20 divided by 2 is negative 10. We got it, guys. The equation of our line that we're asked for is 4x minus 10. The line 4x minus 10 is going to meet that parabola exactly once. And we did this cool trick where we figured that out, which y-intercept was, by making use of the fact that there's one point of intersection, and by connecting that means the discriminant was 0. So a pretty fun question, in my opinion. Again, is it useful for everyday life or later grades? Maybe even later, maybe later grades, yeah, maybe a bit. But that was just an exercise to do, just to tie in various things and get stronger. All right, so what should you guys be able to do? Very simply, given a line and a quadratic function, you guys should be able to set them equal to 0, find where they meet, and find the y values. The example I have up here is pretty typical. Like, if you can do this, you're in good shape. The last example we did was a bit of a stretch, just to challenge you guys. And this example we did here, if you guys should be ready, you guys should understand if you apply the process but end up getting a negative as the discriminant, you should understand, hey, that's okay, and you should know what that means. It just means there's no points of intersection. So that actually wraps up our first unit on functions. So we learned what a function is. We learned some new terminology, domain, range, function notation. We learned a bit more about quadratic functions, but hopefully we reviewed a lot too, and we're kind of getting back in the swing of things. And we developed some new skills involving radicals. So I think we got a lot done in our first unit. Our next unit, we're going to do some more algebra skills and start talking about transformations of functions. So it'll be a lot of visuals, a lot of graphing, a little bit of algebra too. A good mix, should be fun. But until then, Hope you guys are staying well. Have a great day, and we'll see you soon.